Hello. Oh, something is wrong. Let me check. I think now it's okay. Now it's good. I hope you can hear me and I'm not hearing myself twice. Okay, good, good. Okay, that's me. Thank you for joining me like today. It's the extra session. As just to confirm, we will always have Tuesdays and Wednesdays session. And then we will have a GSG leader running for us the weekly review session, probably Friday or Saturday or Sunday. I still don't know what day of the week she will decide to run. But Thursdays will be like occasionally we will have a session. And I just would like to just a really, really quick short session today about the trigonometric, because we know she said Sunday. Okay, thank you, Margot, for confirming. Yes, that means Sunday you can also, yeah, I will encourage you to attend the session. It will be the review, will be like wrapping up the entire week. Yep. And she's excellent. She's really good. Okay, that's me now, because we went really quick through chapter 1, but let's just touch the trigonometric. That we will just solve maybe one equation, and yeah, we will see, and maybe one question. Really quick. Let's say half an hour. Okay. Also, you can check on the YouTube links. I have like I think 2 videos, and I'm solving like extra trigonometric functions like application question. Okay, that's mean you can check that question also, which I think it's placed that question in this presentation. Okay, that's me. Let's see what we supposed to know, because trigonometry, it's quite wide subject, but we don't have to really like go really deep. But what we have to know the fundamentals. That's mean, for instance, unit circle. Okay. Unit circle is the circle with the radius 1. That's the reason that we call unit circle. But when we think about the unit circle, we always think about all of these values. And I don't have to explain everything in details, but we know the special angles, 30 degrees, 45, 60. We also using the radians, because that's the degree, that's the radians corresponding like measurement for this. And then we have this multiplicity of 30, 45, 60 in the second, third, and the fourth quadrant. Okay? And we know what these values means. Correct? What is the first coordinate? What's the meaning of the first coordinate? Do we remember? It's a cosine. That means we can say it's cosine theta and then sine theta. And theta, of course, is the corresponding, that will be theta, corresponding values. And we may see also how symmetric they are, because everything is based on the right triangle, and it's symmetrically we're doing some symmetry in the first, from the first to the second quadrant to the third and the fourth again. That means all of the values are repeated. Some of them are positive, some of them are negative, because of the Cartesian plane. Okay, that's we know all of these values. We have to know them because we will always need them. We don't even know when, but we will always need them. Okay, now the sine graph is helpful, because sine and cosine will be helpful to apply to some like periodic behavior, and especially the sine model and the cosine model. That means this is the sine function. And we probably know the period is 2 pi. Every 2 pi, the situation repeats. We do have a maximum value. Yes, maximum value is 1, and the minimum value, it's equal to -1. Maximum value is happening at pi over 2. minimum value is happening at 3 pi over 2. Yeah? This is for the sine function. Y equals the sine of x. Okay, and we do have 0 as a midline. Yeah, because we need to know a couple of characteristics. That's we have a midline, we have maximum, minimum, and what is the name of that quantity, which is the distance from the midline to maximum value or to the minimum? It's always the same because it's an amplitude. That means this will be an amplitude. Amplitude. Okay. Okay, that's we know amplitude. And now we can also think about horizontal shift and the vertical shift, but that's in a minute. Just for the sine of x and cosine of x, the period is 2 pi because we will do one application. Okay, that's the sine function. And then this is cosine. Yes, that's cosine of x. The same period, 2 pi, just a little bit shifted. It's the one thing it's important because at the beginning, let's consider 0 as a beginning of the situation, of the scenario, and we can see the maximum value is actually happening at that initial point, yes, at 0. That means sometimes this is helpful for some application. Let me come back to the sine. Actually, this is also sine. We can see maximum, it's actually shifted. Yes, it's not starting from the beginning, because when we have a situation like that, something repeats maybe every year or every week or every day, and let's say the maximum value is happening at the beginning, then it's nice to apply cosine function. Yeah, just like the heat, right? Because I mean, we can still apply sine function, but then we will have a horizontal shift. Okay, so we know the graphs, we don't have to. Let me come back to this one in a second. Okay, that means let's just start with a basic equation. Okay, let's maybe solve one, maybe the first one. Okay, sine of x equals to 1/2. That means this is just testing the unit circle. Okay, okay, sine for what angle equals to 1/2? Who can help me? And that's the angle. And we need the solutions from the full revolution between 0 and 2 pi, and sine is positive in the first quadrant and also in the second quadrant. Okay, that means 1/2. Oh, we have to be careful. Pi over 6. Yes, pi over 6. 30 degrees. 30 degrees. And we can come back to the unit circle. Okay, that's yes, that's the value of the angle. Sine for 30 degrees is 1/2. And what about the second quadrant? What will be the reference angle, which is 30 from the second quadrant? If this is x, this is y, we can see this is 30 degrees. It means this is the angle, and we need the same distance here. 30 degrees, 30 degrees. That means this one will be 5 times pi over 6. Yes, 5 times pi over 6. 5 times 30 is 150. That means this one is 5 times pi over 6 or simply 150. That's pi over 6. Okay, that means sine is positive in the first and the second quadrant. And when we are asked to provide the solution just between 0 and 2 pi, we have to provide 2 of them. We can still add 2 pi and another 2 pi. That means if this restriction will be not provided or not needed, then we will need all of the solutions. We will basically add 2n pi. 2n pi. 2 pi then 4 pi, then 6 pi, because every 2 pi, the situation repeats, okay? But since we have the restriction, we don't need that green part. Okay, and then we can do, yes, we can do the other one. Yeah, this one we can also know the angle, because that's the answer is a special angle. We recognize the value. Square root of 3/2 is for 60 degrees, and then this will be 2 times 60. Okay, the first and the second quadrant. What about, since we're talking about this, what about this one? Sine of x equals to 1/3. How we can provide the answer? We don't know the exact angle, correct? Because it's not from the unit circle. We will use the inverse notation. This is arc, not tangent, arc sine of 1/3. And we may use calculator or we may use the tables to get the value. But we will provide the answer like this. This is the first quadrant. What about the second quadrant? How we can write the second quadrant? Yeah, I will say it's something because 1/2 or 1/3, not that far away. That means this one, this angle will be arc sine of 1/3, and we also need this one. Yeah, that means we can see we will subtract from pi, from 180. We have to like get back. We have to remove the same distance. That means we will subtract from pi that angle, that amount of the arc sine of 1/3. Okay, that means please always like think where we are. Okay, that means this angle will be pi. It's the same like this one. That distance is 30, and 180 minus 30 is 150. But we can do the calculation here. We cannot really do on example number 3. Okay, that means this one will be arc sine of 1/3 subtracted from pi. Okay, because this is the same distance, We can see how nicely everything is like symmetric and easy to calculate. And let me put 0, 90, 180, 270, and back to 2 pi, 360. Yes, I said the degrees, but I write the radians. Okay, that means this is actually the way to check if we're confident with the unit circle. Okay, okay, let's leave it. That's the same. That's for cosine. Let's solve maybe this one. Okay, a little bit different. Yes, find all solutions. That means we definitely have to add 2 pi or 2n pi. We will see for this equation. Okay, that means that's a little bit more complicated equation, but not that complicated. 5 times cosine of 2x plus 3 equals to sine 2x plus 3. At least we have the same angle. I can call it 2x plus 3. Maybe I can rewrite cosine theta and sine theta. Let's just put like this, okay? Then it will be at least easy. Okay, that's what we have to do. In order to solve trigonometric equation, it would be nice to have one trigonometric function, one trigonometric ratio. We have sine theta and cosine theta at the moment. How we can change this? How we can maybe rewrite, what about if we will divide? Yes, what about if we will divide both sides by cosine theta? Okay, cosine theta. Of course, we have to be careful with the domain. We are not allowed, we remember, to divide by 0. That means let's just to be, yeah, cosine theta is not 0. Okay, just for, yes, for now. We will exclude this really quickly, but let's just put, because we're doing this mathematical operation. Okay, and then we will have 5 equals to, and what is sine theta over cosine theta? It is tangent theta. Perfect. Let's put unknown on the left-hand side. Yes, that's more natural. Okay, that means tangent theta equals to 5. Also, we don't know if tangent theta equals to 1 or if tangent theta equals to square root of 3. If tangent theta equals to square root of 3 over 3, then we know the angle right away. 5, we don't know. That's not the value from the unit circle. Then we will use, what we will use? We will just use the arc tangent. Arc tangent of 5. But now we have to be careful. This is answer from the first quadrant. Okay, arctangent. And or what is the other quadrant that tangent is positive? Because tangent theta equals to 5, positive. Which quadrant tangent is positive? The third one. Third quadrant, really good. The first one, yes, and the third one. Okay, but now, that quadrant looks like theta. Okay. Now we actually, how we can find, like how we can write this answer. Do you remember like we did for the sine? Because for the sine that was the reference angle and the second quadrant. Now we are in the third quadrant. That means that reference angle must be the same. If this is pi, 180, what we have to do? Subtract or add? This is the second. We have to add, yes. That means we will actually take pi plus that first quadrant angle. Arc tangent of 5. Okay? Yes, I will erase because we actually adding. Okay? That means you will know how to deal with this. And what we have to do, we just have to solve this for x, because now, do you remember what I did? Just for the equation to look a little bit more simple, I just replace 2x plus 3 as a theta. That means let's just replace it back with the original variable. 2x plus 3 equals to arc tangent. Oh, one thing. We have to include all of the solutions. What is missing? Let me do this. 2x plus 3 equals to pi plus arc tangent of 5. Okay, what is because tangent is also a periodic function, but what is the period? What is the interval that tangent will repeat? The situation will actually repeat. Sine function repeats every 2 pi. Cosine every 2 pi. What about tangent? Do we remember tangent? Tangent is not one tangent curve, another tangent curve, another one. What is this distance? Because that's the period. Between negative 2 pi and positive 2 pi, how many units we have? 1 pi. That means every pi plus n pi. N is a positive integer. 1 pi, 2 pi, 3 pi's, and so on. That's we have to add n pi. Okay, because we're not only restricted to the full revolution 360, we want to include everything. Okay, and now we just have to solve for x. Yes, we know algebra. Okay, shall I do really quickly? I will subtract 3 from both sides and divide by 2. 1/2 arc tangent of 5 divide by 2 and subtracting 3 and divide by 2. I hope that's okay. That's correct. And the other one is dividing by 2 arc tangent of 5 dividing by 2 and subtracting 3 and also dividing by 2. Okay, that's the final answer. The last lines. Okay, we're just solving for x. We just want x. Okay, That means that's the solutions. Beautiful. Yeah, really nice. Okay, that means we know how to solve basic equations. We know how to solve a little bit more complex equations. Let's keep moving. Oh, no, we have only a couple of minutes because I don't want to keep you long. Okay, you can do the same thing. This one actually, it's nice because it's only one trigonometric ratio. You can isolate sine on one side and then solve it. What about this one? What's wrong with this equation? You can also do the same thing, yes? Like you can follow but what, something is wrong. Come on, really quickly, I can give you 10 seconds to answer. Cosine of, we can call it theta if it's easier for us. Cosine of theta equals to 5. Doesn't sound wrong? It's too much. Yes, what is too much? That's the good answer. Laura, that's the good answer. 5 is too much because what's happened? Cosine, if I would like to draw, oh, that's actually sine. We're starting from the maximum. Cosine, let me draw it like this. Yeah, and this will be 2 pi, half, 3 halves, and let's say this is theta, because the maximum value and minimum, what is the range of cosine? Or sine? The range is between, yes, thank you, -1 and 1. That means if I would like to find out where the cosine equals to, for instance, 1/2, I can draw the line and this will be the solution, theta, maybe theta 1, theta 2. Let me, yeah, we can see. But when I will draw the line 5, let's pretend that this is 5. I will never intersect the cosine curve. And that means that's not possible. For this one, we have to say no solution, no such a x, no such a like angle that the cosine will be equal to 5. Okay? Be careful on your homework assignment. Okay, and then this one will be good. Okay, now really quickly, let's solve one application. Okay, let's solve one application and we will be done. One like word problem. Because yes, the graph. That means this is important. We call sinusoidal model, sine model, but when we saying this, we also think about the cosine function because its cosine is just shifted differently. But all of these letters, all of these parameters, A, B, C, and D are important. That when we see the formula like this, yes, we have to know A, it's an amplitude. Yeah? If it's nothing, means 1, we had the standard graph. But if it's a little bit bigger, we will have this. C is a horizontal shift. That's like from algebra. When we subtracting quantity from x, we're shifting along the x-axis. When we subtracting or adding the quantity to the entire function, like plus d, this is the vertical shift. Yeah? It's actually, it will be, oh, supposed to be I, midline. Because when we're shifting the midline. That means this also represents the midline. But it's definitely the vertical shift. Yes, vertical shift is the easiest. Yeah, I know. And then B is a little bit maybe weird quantity because it's not telling, it's actually the frequency. It's a frequency. Like for instance, when we will have sine of 2x. Yeah? That means this will tell us that in the original period 2 pi, we have to squeeze 2 times sine curve. Yeah, that means I don't know if it's helpful number. Yeah, that means I will have 1 sine curve. Oh, and another sine curve, and this will be 2 pi. If this will be 3, I have to squeeze 3 times the sine curve. Okay, that's the frequency. But what is helpful to know? It's helpful to know this, that if we will take this quantity b times the period, yeah, we will always get 2 pi. That means bp equals to 2 pi. Okay, just yeah, bp equals to 2 pi. Then we can calculate the period. But actually, yeah, if this is, let's see, sine of 2x. That means what is the period of this function? Yes, it is important. Correct. Yeah, like we can see the quantity b is 2, and when I say bp equals to 2 pi, period is 2 pi over b was 2, it is pi. Yes, because when I squeeze two sine curves between 0 and 2 pi, of course, it will take, for one of them, will be take pi. Yeah, that means it's worth to remember bp equals to 2 pi. Okay, yes, we know. And yes, the period, of course, is always 2 pi. This exercise, let me check which one we will solve. I am solving this one on the additional video. You can check. I am solving this one also. Solving this one. Then I will not repeat. Oh, which one I'm not solving? Let's look at this one. We have lots of questions, but what is important? It's important to get the nice graph and to get the formula. Yes, we have to get the formula for this scenario, trigonometric formula. Okay, that's what we have. In a particular city in the northern hemisphere, the number of sunlight hours oscillate between 10.5 and 13.5 hours on a yearly cycle. Okay. The longest day, the maximum. The longest day is the summer solstice, which is 172 days after January 1st. Okay, we will have doesn't matter, even if we use sine or cosine, we will have a vertical shift, because I'm assuming that at 0, 0, we will have January 1st. And since it's the yearly cycle, how many days we have in the year? 360, I think it's 65. Let's just use 4. Okay, let's just use because it's even number, it's maybe, I don't know if we have to, actually it says 5, but no, let's just use 4. I think will be easier to maybe calculate. We can use 5, but let's just use 4. I don't know if we need, sometimes for the easier like division on. Okay, that's what we need. We definitely need answer the following questions to build a sinusoidal model, meaning sine or cosine. Sinusoidal formula for d of t, the number of daylight hours as the function of t, time, where t is the number of days after January 1st. Okay, that's what I think we will use cosine anyway, because it will be easier. Then this will be the shift. How we can start? First of all, let me write down the formula. A cosine B t, this is angle t minus the vertical shift, and plus d. That's we have to find out all of these parameters, A, B, C, and D. You will help me. And let's use cosine. Do I have room? I have the room, okay. But let's try here. This was good, because nothing will be negative. I'm just trying to plan. Okay, that means this is hours, right? Number of hours. Hours, and this is days. Days. Okay. January 1st will be January 1st is the beginning. Okay. And what is the maximum value? Maximum value, which is maximum number of, I mean, the biggest, yes, the longest day is 13 point hours. Let me maybe draw cosine, and I will shift, okay? I will shift up vertically, and I will shift like horizontally. It means maximum value somewhere here, midline, minimum, midline, maximum. Okay, that's we can see it's cosine, but I shifted, and we have to know this is the midline. Yeah, that's how I will recommend to do. Sine is different. Yes, sine will be like this. Sine will be up to that point, but I pick cosine. Maybe we will need these days, but it's fine. Okay, maximum hours 13.5. Minimum, what's the minimum? 10 point. 10.5. What is the midline? Because the midline means that we shifted that cosine from 0, and that will be the d value. This will be the d value because we shift, we lift that amount of, that's what is, it's between 10.5 and 13.5. We can add together and divide by 2 really quickly. Who can help me? Who can help me? 12. Yes, thank you. That means D is 12, midline. We do have quantity 12. We just need all of the quantities. That's it. Okay, that means this is 12. Good. What is A? What is an amplitude? Oh, my pen. What's the amplitude? 3? Oh, let's see if it's 3, because an amplitude is that distance from the midline to minimum or maximum. That's A. Oh yeah, we still have to divide 3 by 2. Okay, that means this is an amplitude, and it is 1.5. Perfect, 1.5. Okay, now please tell me this number. How many days we actually have that maximum? Where is the longest day? Yes, this is 172. I don't know, it's somewhere in the summer, because when we divide 172 by, let's say each month is 30 days, just roughly. 172 divided by 30. What is 172 divided by 30? How many times 30 goes to 172? 5, almost 6. Yes, almost 6. That means it's like middle of June. Yeah. Yeah, and actually, yes, middle of June is, I mean, end of June, yeah, 21st of June. I think it's the longest day and the shortest night. Yeah, June, yes. Okay, but yeah, 172 days, I think it's June. I just divided by 30. Okay, that means that's good. Everything is perfect. And actually this one, because we just move cosine, that means what is this, which of these parameters, B or C, is 172? Well, it's a C. That means this will be 172, okay? And then what about B? Who can help me? What about B? We just need this. Oh, maybe we will need this one also. How we can compute B is just 1? Let's actually check. We remember, what is the period? What is the period? What is this distance? This distance is actually, no. The normal, the regular, the general period for sine and cosine is 2 pi. But in our scenario, it's 1 year, 364. Okay, it's 364 days. That's the entire year. because we can see that's the entire model. And we can add, if we add 364 to 172, oh, I don't know, it will be another June, 538, 8, 3, I think, yeah. But this is, yeah, that means this is P, this is period. And now how we can calculate the quantity B. BP equals to 2 pi. Always the period times the frequency has to be 2 pi. Period times the frequency, 2 pi. And then what is the B quantity? B is 2 pi 364. And we can even keep this form. We can simplify, but we can keep it. Okay, we have the entire model. Okay, we have the entire model. That's it. I mean, I didn't read all of these questions, but I kind of walk you through the different one. Okay. Yes, yeah. That means this is the quantity B. Always the period times the frequency must be 2 pi. Okay, that means let me copy this, and we will just solve one equation and we will be done. I know we're supposed to finish earlier, but yeah, just this one, because I want you to. Do I remember this? Okay, 1.5 cosine, and then 2 pi over 364. Oh, no. Oh, I cannot write. Let me write a little bit lower. Sometimes I cannot write on the top. D of t. 1.5 cosine 2 pi 364, and then we shift 172. Oh, where am I? Here, and then plus, what was the shift? What was the midline? 12. Okay, that's the equation. Really nice, really nice. And then maybe on the test, I can ask you just to find one of these parameters, maybe A, maybe B, maybe C, maybe D. Okay, but please make sure that you know this. And what I wanted to do, I wanted to solve part B. On what days of the year are there at least 12.75 hours of a daylight? That's where is actually, let's use purple. Somewhere here, 12.75. I can draw a purple line, and we will need this number of days. Let's say question mark. And actually, probably when we will be solving, we will end up having that number. But we can always add 364 and have the other values. Okay, let's actually find out this. Okay, this question mark and this 2 question marks. How many days or which month? How many days after January 1st? The day has 12 hours, I mean the sunlight, 12.75, 12 and a quarter. Okay, that's what we have to do. We have to solve this equation. This has to be equal 12.75. 12.75. Okay. Okay, let's solve this equation. Okay. Then how we can solve it? What is the first step? I know that looks not nice, but I promise it will be easy. Yes, thank you. I will do this. Yeah, do we see the suggestion? We have to subtract 12. Let me copy cosine. I can keep this one for a second. T minus 172 and equals to 0.75. I did subtract 12. What is the other step? I can maybe write this. 364, T minus 1. We have to divide. Oh, 0.75. divide by 1.5. Who can help me? Yeah, we don't really need a calculator because 75 is 3/4, divide by 3/2, dividing by fraction means multiplying by the reciprocal. 2/4 is 1/2. This is 1/2. We can see quick algebra. Okay, and we like 1/2. Let me write. Oh, maybe this one I can simplify. What is 364? That was the reason that I used 4. 364 divided by 2. 364 divided by 2, 172 or 182? 172 or 182? 182. Okay. Okay. That's me now. Cosine. That's the angle, right? That's the entire angle because it's everything. Cosine of that angle. Cosine for what angle is equal to 1/2? And I can maybe, that's the angle. 172. That's we need the first quadrant because cosine is positive in the first quadrant. Okay, cosine for what angle equals to 1/2? Really quick. Pi over 60 degrees, pi over 3. Or you can of course you can use arc cosine of 1/2, but we know cosine, yes. Let me maybe write this. Cosine theta equals to 1/2. That's what I ask. And then theta is pi over 3. Or we can use this. That's the reason that we will move, we can see, to that part. Because if I will use the fourth quadrant, I will get that question. It's still fine. But I just use that question mark minus this one because cosine is positive in the first quadrant and the fourth quadrant. Okay, the first one and the fourth one. And we can use the negative notation when we're going clockwise direction. Counterclockwise, yes. Okay, but now theta is actually this. Yeah, and with the only thing that we have to do, we have to solve it for t because we need t. Okay, let's finish this. Yeah, because this is, I don't have a room, but I can make it room because I want you to be confident with this, just in case. Okay. That means theta, which this is the entire theta. Theta is pi over 3 or negative pi over 3. Let's see what we will get. I just want to make sure that everything makes sense. Okay, that means theta is, do I have? Theta equals to pi over 3, pi over 182, t minus 172 equals to pi over 3. And then we have to solve for t. How we can do it? We can keep pi over 3 multiplying by 180 over pi and then add 172. This is gone. 182 divided by 3 plus 172. Oh, this one is 60 and 2/3 plus 172. Am I right? It will be 232 and 2/3. Okay, 230, almost 33 days. What's the month? Because this is days. Yeah, no calculator. Okay, when we divide by 30, 4. No. What's more? 6, almost 6. No, 7. A little under, yes, a little under 8. Yes, a little under 8. That means middle of July. Yes, like July. No, middle of end of July, right? Because or middle of August. I'm just, let's say end of July, yeah, approximately. Okay, and now we have another one. Am I writing? Let me write a little bit lower. Negative pi over 3. Then we will have pi 182 t minus negative pi over 3. That means I can maybe skip all of this. It will be negative 182 divided by 3, because everything is the same, plus 172. So now we have to subtract. Oh, who can help me? 111 and 1/3. Please double check. What is 172 minus 60? It's 112 and minus 2/3, 1/3. Okay, that means also days. Yes, thank you for. And this one will be around 112 divided by 30. End of April. Yeah, because it's less than 4. End of April. Yeah. What I'm doing, I'm just dividing by 30, and I'm looking what is the number, and we know months, the first one, the second, the third. Yeah. Just in case if you are a little bit confused with the last line. Yes, I'm just dividing number of days by 30. You can still count the days perfectly. January, February, a little bit shorter, March, longer, April. Yeah, and then, but let's just do roughly. Okay, let's maybe put these values, and I hope they make sense. That means one of them is 111 and 1/3 of the day, makes sense before. And the other one was, another question mark was 232, and actually not dot, and 2/3. Okay, that means, and also makes sense. 172 is in the middle. Yeah, and actually, yeah, 172 is exactly in the middle of this. Okay, that's been end of April, end of July. Yeah, we have this 12. Yeah, because the middle of end of June, we have the longest day, which we're waiting now for this day. Okay, that's mean just to show you how we can deal with the sine or cosine model. Okay, let's just finish. Please, but please check similar question I'm solving on the other video. And the rest of the questions, you can just check the solutions on my notes and make sure that you can solve it. It's just the basic, the fundamentals. Yeah, I believe this was a little bit more like complicated, but still nice. If you will look at the front page, the front Canvas page, I think in the middle I said Kasia's YouTube videos. Okay, that's that always too. The media gallery is for the live sessions, and I also add a couple of YouTube videos, and you can check. Okay, the middle of, and I will put more and more the additional videos. Or okay, if you look at the front page, it's like Mat 140 Kasia's videos or Kasia's YouTube videos, something like this. Yeah, I can double check. You can check. You will see. Okay. Thank you very much, and see you next week. Good luck with your chapter 1. Next week, we will start calculus. Okay? We will start calculus. This was just a review of algebra and pre-calculus. Thank you. See you next week.